Okay, we'll start this week, week 11. So these are mostly of theoretical questions. So first question, which of the following involves lowest risk and is most preferable option? Four options are given: reduce water consumption in wastewater generation, reuse the treated wastewater for alternate application, recycle the treated wastewater for the same application, treated waste disposal. So which involves lowest risk and most preferable option? Any answer? Okay. I hope you can hear me. Okay. So the answer is A. So reduce water consumption and wastewater generation. So because which one involves lowest risk and then most preferable. So here if you understand the option A, uh, the wastage is happening, it is directly proportional to how much water we take daily for our daily needs. So if we reduce the consumption, then the wastewater generation is also less. So in B, reuse the treated wastewater for alternate application. So here, this need again the wastewater which is generated has to be treated by different technology, and then depending on the different technology, the we have the potable water, and then we have the concentrated stream. And this in this potable water, we should understand what is the TDS, and then we should understand the physical and chemical properties of the resulted water. Accordingly, that water can be applied for different applications. So whether is suitable for the agriculture, or it can be utilized for the factory, or we can consume. So these all depends on the final water composition. Then the third option is recycle the treated wastewater. So even this also need more steps, or treated waste disposal. So treated means we are treating the concentrated brine, then disposing the like after extracting some of the water, and then we are disposing it by removing some of the pollutant, and if it's a safe if it's safe for land or soil, means land or soil, or some water sources, then we are just disposing. Or we you all heard of the deep well injection technologies and all. Deep well injection. So these all technologies like need more step. You need to treat, then you have to understand the composition and all. But when we see the first option, reduce the water consumption, that is very simple, lowest risk and most preferable option. Second question, wastewater reuse and recycling is attractive because options: it is good for human health to use recycled water, or b, recycled wastewater serves as an alternate water resource, c, recycled water is usually cheaper than fresh water, d, all of the above. Wastewater reuse and recycling is attractive because of which option is more suitable for the question? Any answer? Which one? Yes, yes, right. Yes, true. This option only. Recycled wastewater serves as an alternative water, so that is true, right? So, because this first option cannot be, it is good for human health to use recycled water, then recycled water is usually cheaper than fresh water. Might be recycled water is more costlier than the fresh water that we take from our surroundings or pipe water that we get from our municipality and all. So, option B is the right answer. Then, the correct flow for large wastewater recycling system combining various stages is correct flow of large wastewater recycling system. So you should the system should have sewage transport, treatment, collection, reclaimed water transfer, designated reuse. So these all are there, then you have to arrange it according to the flow, like from initial to final. Okay, Sanjay said it's what options you given? D. Yes, D is the right answer. Yes. So first collection, you have to collect the wastewater from different sector from where the generation of wastewater is occurring. Then the sewage is transported to the treatment plant where it is treating. Then the treatment is happening. Then reclaimed treated water is again transporting to the designated reuse. Okay, this is the right answer. D is the right answer. First collection, that wastewater generated from even home. If we say that home, this is home, then collection, we collect, then what happens, then it is transporting, then there is a treatment facility, this is transport, then treatment facility is there, then what happens, the treated water is sent back to each again. Then also the concentrated one will be there. If it's not zero liquid discharge, there should be a quantity of concentrated brine. Then this become a problem what they have to do. So anyone has comment that what is um, ZLD, NZLD? Yes, yes. This one, this is just near zero liquid discharge, and this is near zero liquid discharge. Zero liquid discharge, that we are consuming, we have a waste stream. We have a waste stream, then we correctly separated water and then solids. And this is pure water and this is solid. So in near zero liquid, what happens? We may produce three. One. Okay, what should I write? How to? Okay, this one, two. See here, water, then solids, some minerals that we have separated. Then we also have a stream, some minimal stream where water plus solids will be present. This quantity will be minimum. So that is near zero liquid discharge. We have approached to zero liquid discharge, but still there is some quantity of the concentrated brine is produced. That is near zero liquid discharge. Next question. Which of these pollutants are of major concerns for recycling wastewater? So when we recycle wastewater, which one of the pollutant is a major concern? A. Suspended solids. B. Nitrogen and phosphorus. C. Emerging contaminants. D. Biodegradable organic matters. Any answer? Any idea? Which is major concern when we consider all these four options? No ideas? Which one? I. Which one? Yes, yes, right, right. Option C. Option C is the right answer. Emerging contaminants. So why this is like we it has some major concern because see here emerging contaminants I have given the the statement. Emerging contaminants are chemicals or materials they may be threat to human health or environment for which there is no published standards. So here you can see when we analyze all other things suspended solids sediments nitrogen phosphorus or biodegradable organic matter we know that what happens if some the quantity if it's above some limit like how it is impacting our health, that all we know. But for the emerging contaminants for about antibiotics and all, so those things like even humans are also like if we have some disease also we take antibiotic, but the end it not that much wide research that the effect after effect is not that much well established. So you see that for example, of emerging contaminants include antibiotic resistant genes. These genes are result in the intensive use and misuse of antibiotic in humans and animals. Then some of the hormones. These have estrogenic and androgenic um, effect on biodiversity. Triclosan, this antibiotic is a common component of hand soaps and toothpaste. Yeah, so these all things. So he see here we use soaps also. So even when the water get contaminated with the soap water, this all these antibiotic is directly going into back we that water is going into the backyard of our home, or if we have some municipal collecting pipe then it is going directly there. So how these these things these antibiotic affect the soil system, or if it's going into the groundwater, or these all things are not well studied. So these things are have to be studied, but we don't have that much knowledge on it. So this dealing with this emerging contaminants is a very significant concern for this era. Okay, next question. Irrigation of agricultural fields with treated sewages. Irrigation of agricultural field with treated sewages, direct use of wastewater, indirect use of wastewater, disposal of wastewater. D. None of the above. Irrigation of. Yes, A only. I said like use, I guess. It's reuse. Okay, it's the right answer. Direct reuse of wastewater. So, what we are doing is wastewater is collecting and just treating, and if that the chemical content inside is fine with the agricultural field that we have, for different agricultural field, it different crops. For different crops, for some crops, salinity is fine. Some crop the salinity should be very low for them to grow. So according to that standards, if our treated wastewater is reaching, then that we can use it for our irrigation. So this is called direct reuse of wastewater, that is after treating the sewage. So disposal is not right, because disposing means we are not treating, just putting it. Indirect also reuse is also not, we are just directly treating and putting the same water into the for the irrigation. Next question. Direct reuse of Treated wastewater should be avoided for gardening and landscaping, drinking and cooking, floor washing, toilet flushing. Direct option B. B, right? Yes. Drinking and yes, drinking and cooking. So we should not use the reuse the treated wastewater, direct reuse of treated wastewater for drinking and cooking. So I told you, like, not every treatment. So you know about distillation, MD, membrane distillation. Have you guys heard of membrane distillation? Multi-stage flash distillation, MED. So then RO, then RO is, so in India, RO plants are much more, high, and MSF plant is there. That is MSF and MED is the thermal based technology, heating the wastewater, then collecting the vapor in different compartments. So MD means what it is doing is, see, MD it is doing, there is a membrane which is hydrophobic, then it has a cold stream in the front side, and from here we apply our treating wastewater. Then due to the here it is heating also, we are heating the water also, and then there is a temperature grading generated, so the vapor transfer from this side where the temperature high to the lower side. So then we are collecting the vapor from here and condensing in MD. So in each treatment technology, after the treatment process, the quality of water that is generated will vary. So RO, even if you do RO, after RO also you have to do some more techniques to treat the, if you want to drink, you have to do much more steps. So here in MSF or MD, or even MD also, the vapor is going through the pores and reaching into the condensing chamber. So in MD, when we compare to RO, this MD quality, we can say that it depends on the type of wastewater is we are using, but still the quality would be good. So according to that, for different treatment technologies, different type, the quality of water will be different. So you can't directly use for your drinking and cooking. For that depends which treatment you are using. Mostly in India we are using RO. Okay. So that, the this treated wastewater we can just use for the in, I think, in many of the in some of the schools also they have started, not the very dirty means water, but some, the minimal treated water they are using for toilet flushing. And even floor washing also, we should have a certain, some which is safe for even our floor washing. Otherwise that will also get damaged, or that if some bacteria and viruses are there, then that will, some dangerous bacteria are there, then if this floor washing, it can also, is if we have small kids and all, that will come on them, and that can be again have a problem. So that all, it's a complicated, but it should not be taken for drinking or cooking directly. The disadvantage of separate grey water recycling over sewage recycling is, separate grey water recycling over um, sewage recycling is, a, treating grey water is difficult than treating mixed sewage. A separate grey water collection system would be required for grey water recycling. Treated grey water has lesser social acceptability than treated sewage, or the above. Disadvantage of separate grey water recycling over sewage recycling. Any idea? So the answer is B. A separate grey water collection system would be required for grey water recycling. We need a separate collection system. So, what is grey water? Can you recall from the first lectures? Washing of clothes. Okay. So, what about what is the difference in that um, um, toilet flush and all? Black water. Yes. So then, even that grey water has lesser social. Is this statement is true? Treated grey water has lesser social acceptability. Not thinking that treated grey water has like less social acceptability. Maybe black water. Maybe it has, right. Black water. So I think black water has lesser social acceptability than treated sewage. I think like this thing. And okay, then B, separate grey water system would be required for grey water recycling. That's why that is the advantage of separate grey water recycling over sewage recycling. The most preferable option for industrial effluent manage is treating and recycling it for industrial processes or other uses within industry. Be treating and discharging it in nearby river or lake. Then see groundwater discharge with treated effluent using evaporators for complete evaporation of the effluent. Most preferable option for industrial effluent. Yes, right. A is the answer. Treating and recycling it for industrial processes or other uses within industry. So it will be easy. Means it is all means after treating also, if some content is there, if it's okay for the industrial, for their process, that is very easy. We don't need any next step of treatment. So that first option is the right. Then the second option, treating and discharging it in the nearby river or lake, is not a good option. Even the treated one, the initial treated one should be having some chemicals that will change the chemical composition of the river or lake. Then groundwater recharge also, it's not a good option. It will contaminate the groundwater. Also using evaporators for complete evaporation of the effluent. Is this option, this one, do you feel that this is also a good option? So evaporation ponds. So there are evaporation ponds. What they are doing? So the wastewater which is generated in the plant after treating, we can make a pond like structure, manual structure, and filling it. Then what happens? Then daytime, from the solar radiation, the heat energy will come, and then due to this thermal energy which is from sun, it will start evaporating. Then after the evaporation, water will go, then remaining minerals will be stay in the bottom. So the disadvantages, it is like a lot of area is consuming, and then also it is a bulk heating process. So bulk heating means we need a lot of energy. So that means like if it depends on the day also. If the solar radiation, if it's a rainy day or if it's a very cloudy day, then it will affect the process of this evaporation ponds. So this is bulk heating. So other than this, using evaporators, this is evaporation ponds. Other than that, we can use evaporators. What you say evaporators? That means there are different surfaces. So you have heard of interfacial evaporation. So what it is doing, interfacial evaporation, we have a surface. Okay, then this surface is a photothermally active surface. That means it can absorb solar radiation and it can convert the solar radiation into heat energy. And also the surface is porous. This is a evaporator. Then what you have to do is you have a brine. So this is the brine. Then you should have a vike. Means vike means it is a capillary media. Capillary. So when this capillary medium is attached with the brine and the interfacial evaporator, it will transfer the brine to the bottom of the surface where the pores are there. Even the surface is porous, and the heated surface will start evaporating the brine. Then the remaining crystal or minerals are here in the bottom. What is here compared to evaporation ponds, this particular setup need less energy. So now for interfacial evaporation there are more researches are ongoing, this particular. So this is also one of the option, but I think it will take some time to optimize the operation. Next is groundwater recharged with treated wastewater is an example of groundwater recharge with treated wastewater is an example of wasting of treated water, indirect reuse of reclaimed water, direct reuse of reclaimed water, D, none of the above. Which one? Any idea? Sorry. C. No, the answer was B. B. Indirect reuse of reclaimed water. Why it's so? Okay. So, in what type of wastewater, like for just give me some any example you can tell after treating like this water, then they are injecting to the ground level. I think this oil industry, heard of this oil industry, and I have told this deep well injection. That is one, but this particular case in oil industry, the water which is taken out, is like after the treatment, even the concentrated, this water, it is again injected back to the ground. So this particular solution is not only water, it has a oil content, or if it's at petroleum, it's not petroleum, like it's type of oils, it's fully oil, it's not a clean water in oil. Some other example you can give, any other wastewater industry which recharge groundwaters? Okay, okay, which industry? I didn't heard sorry. Yeah, yeah, you're saying about the factories, or factories, okay. Yeah, okay. Then this I have just given reclaimed water that we have already studied, treated and purified for reuse. So here I have see given the direct use and indirect use. Direct use means immediate application for specific purposes. Indirect use means further treatment or mingling with some other water sources is needed for indirect use. So here direct use, here you can see irrigation, and then the industrial processes, then toilet flushing, fire protection system. So indirect use means groundwater recharge, surface water augmentation, then drinking water supply after extensive treatment. So okay, now the implementation component of WHO guidelines for wastewater reuse. A, establishing monitoring and assessment mechanisms, defining institutional responsibilities and accountability, C, independent surveillance of the system, D, all of the above. Implementation component of WHO guidelines for wastewater reuse. Option is D, all of these, establishing monitoring and assessment mechanisms, defining institutional responsibilities and accountability, independent surveillance of the system, and all of these. So, in many countries, developed countries, so if you go there, these guidelines, even WHO guidelines, and after that, the government guidelines is there. How can you treat, like the treat, even if a factory is there, how much after treating factory, so if they produce some wastewater, that has to be treated, or it should not directly dispose to any of the street, nearest water bodies or soil. So their strict laws are there, but in India, these rules are very loose. So people, many of the factories, if you see, they just directly discard, even in the soil or in the water source. If some river is flowing behind their factory, they just put a pipe to it and then it will go. So it is very, in India these rules are not that much strict. So hopefully it will change in the future, but that is what these guidelines they are following. Even in all the developed nations, if we go, there is cleanliness. Even if it's a very big factory which which produces this waste water, they have proper system to treat it and discharge. So in Rajasthan, you just see Rajasthan has RO treatment plan. Like our Rajasthan is a landlocked region, and also in Rajasthan, the water in the groundwater is saline, right? That saline water mainly in Rajasthan they are treating this brackish water. Brackish water means it is less saline than the sea water, which is in sea water approximately 3.5 percentage of 3.5 percentage salinity, but in water it is less than that. But they what they do is they dig underground pipe, then they will take out the water, the saline water from the underground. Then what they do is they will treat. For example, they treat by RO technology. Then RO, there is water which is a purified water. Then this is concentrated. Then these concentrated stream, see, in Rajasthan there is no they can't link to the sea easily, marine region marine. So what they are doing is, like in many of the regions they are just directly putting in the on the land. So that is the important issue there. There is no not only in Rajasthan, there are different other part of India also, like plan these treatment plans are not that much following their uh, you know rules. But in some of the system, I think I will give you some photo with some examples. Zero liquid discharge technologies are also there. Not zero, maybe near zero liquid discharge technology is also there in started in India. Those people, what they are doing is they are maximum water they are extracting, and then also they are extracting minerals. What they you all of you know that lithium, this lithium has a great this century, this lithium extraction is a major research topic. Lithium has a lot of values. Lithium ion batteries are there for the energy application. So in many part of world they are utilizing this extracted minerals for the for their energy requirement. Okay, that we can just remember, just keep in mind, these are some of the points that it will be useful for your next research or something. Okay. Which of the following should be considered for water reuse planning? Ensuring protection of public health and environment, ensuring implementability, technical feasibility, and economic viability, ensuring social acceptance of the project. D, all of the above. Which of the following should be? Yes, right. D. Ensuring protection of public health and environment, ensuring implementability, technical feasibility, economic viability, ensuring social acceptance of the project. So these all needed for the water reuse planning. Next is for agricultural water reuse. Four options are given. Untreated sewage can be directly used for irrigation without any health risk. B. Secondary standard treated wastewater is suitable for use in drip irrigation. Then level of treatment must be decided based on target crop. The wastewater must always be treated up to tertiary standard before agriculture use. So for the agriculture, C, right. C is right answer. Level of treatment must be decided on the basis of target crop. So if the target group is fine with the higher, mineral content, this salinity, it is fine. The plants which we are seeing in the estuaries, they don't have much problem with the salinity, so they can easily grow. But then when we consider some crops, uh, even I can't give some examples, but the normal plants that we are seeing in our home, or if we have some vegetable crops, so those things, it won't sustain in the heavy salt content. So you have to decide the level of treatment based on the target food crop. Then 13 question, in the recent times, packaged treatment plants are being used for wastewater treatment and recycling by cluster of residential apartment in major cities, commercial units such as big hotels or hospitals, C, small manufacturing units and factories, D, all of the above. Answer is D, all of the above. See, this is the treatment plan which is small scale, that can be easily we can employ from the cluster of residential apartments in major cities. That can be like each, it is not mixing the waste. Okay, in commercial units such as big hotels they can also, for their own, they can start a treatment plant. And hospitals also, hospitals are much variety of this waste stream, so you can't mix this hospital waste with some other waste and treat. But it's better to treat the hospital, for the one hospital, if they have their own treatment facility, they can treat it, and then they can extract the maximum thing they can get, and then that extracted also can be sent. If some some companies are buying that, if something can be generated, that can be sold. And then small manufacture. Yes, yes. It is small scale treatment plants. Should need some photo. Ready made in the sense, but you have to build in a small scale. It's a decentralized one. And also they most of them uses some biological aeration to the treatment plant. But also you can, I will give some, it's a compact one. I hope that if you call some, they should be some like a solar panel. We call some people like for the installing in the home. So like that, the people come and then they can install in a small scale in this things, and it can work. It's mini. It is. It is like yeah, it not all the parts are portable, but it is like a, when we compare the big treatment plants, it is portable, we can say. Then the people who install, no, they can come with the system, decentralized system, and installed in a smaller area that has a small footprint, spatial footprint. And that doesn't need much civilian work also, like though there is no need of several workers in a small scale. Or you need some photos? Okay, I will give like some photos if I can find. So it is okay. I will give some photos. Yes. Next section, I will collect some photos and I will just give. Yes. Then, uh, in decentralized management of wastewater, four options are given. A city scale wide network of sewers is required for wastewater collecting and transport. Next option, collection, treatment, and reuse is done at or near the point of generation. C, treatment is done at off-site location outside the settlement. D, all the above. Yes, right. That is very easy. Like centralized and decentralized. In decentralized, collection, treatment, and reuse done at near point of generation. In centralized only, we need a larger transport system, and we have a very big treatment plant. These all collected sewage will come there and treating. Decentralized will be in the decentralized manner at the generation of the wastewater. There only it is treating. That is the decentralized. Then the last question, last question. The major issue with centralized system for wastewater management includes it requires more number of treatment plants. B, it's always costlier than decentralized system. C, long distance transport of water is wastewater is needed. All the above. The major issue. Yes, right. It's longer transport, like in longer distant transport is needed for the wastewater compared to the decentralized generation. A source point, near the source point, you have the treatment that you know. But in the centralized, you have a big treatment plant. You have to collect from all the points like that. So here you need a long transport pipes like branched, and so these all will be very tough to handle. If some clogging or something will happen, if some leakage is happening, it is very difficult because it has a longer way to travel to reach to their treatment facility. Okay. Now I will just take a 5 minutes break. Then I think this question, I think in the previous class, I think couldn't complete this question. So I will just start from the option, means from first question only, and this three sub questions are there. So this will I will cover. Okay. Then after 5 minutes, we'll start. Okay. Thank you. Okay. Okay, we'll start. So I hit here. I will check this one. See here, you can see. I hope the screen is visible. See here, you can see packaged wastewater treatment plant. So here, when you check also packaged waste treatment plant, you get some, different companies who are doing it. So here, you see here different. This is Alpha Level India. This is Wastewater Limited. It's a company. So like that, you will get different, manufacturers which they manufacture, and you can, fix in the where you want it to fix it. So like that we can get the quotation. So like that you see here, packaged seawater treatment plant means wastewater treatment plant, also known as package plant. It's a prefabricated system that treats wastewater in a small communities or individual properties. So it's a very small thing. It's a small, you can't treat with very from the uh, high volume or mixed, or if you consider a multinational factory, so it's a big factory which process a billion liters of water. So that you can't do with the small setup, but you can treat in a small like you see the systems, they will come and fix. This is decentralized package wastewater system. Understood? Yes. Okay. Then one more. Sankamitra, you were asking this now. This one about the attaching media movement, right? In the previous class, attaching media movement. That one was the question, right? I hope. So here SBR. So the difference is here, biofilm is coming, right? Here also. So when you see here, you know that I have also one in the previous class there was some growth mechanism was there, suspended and or something like, I will just show that you remember. I hope you remember, there was some picture also I have shown. See this one, suspended growth and attached growth difference. So here in the attached growth, in the biofilm it is the microbes are attaching in the biofilm and growing, and in the suspended one it is in the water, it is flowing, it's like a floating, and the food we are providing in a suspended manner. Here here when you see the SBR, like we have discussed, no media, that means it's a suspended growth. The microbes are in the wastewater, and it is in the suspension form, and we are providing the food in the wastewater itself, it is also in the floating form. Floating in the sense it's in the movement, it's in the suspended form. Then no fixed media is used. Here in SBBR, fixed or stationary media, it is not moving, okay, it's a fixed media is there. That media is plastic, the ceramic or stones, these all things can be used. In MBR, it's a membrane filtration, and this is fixed. In MBBR, moving bed media, that means like plastic carriers they are using, it is moving. Any more confusion in this? Okay. Ha ha. Yes. 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 I thought yes. MBBR. I thought it's semi also can possible. I was confused. This one. Yes. It's a moving media. Yes. Okay. Density. Okay. Which one? Hydraulic retention time. You're saying? Okay. Density. Mm-hmm. Okay. Okay. Yes. Yes. Uh huh. Yes. That one doubt was there. Yes. I think it was. Yes. I forgot about that. Okay. I will. I think there was some density variation. Yes. This one, right? Is this one, right? Okay. Actually, I forgot about this question. Okay, I'll let you know about this. Yeah, because we from here, um, I think this was the lowest density, right? Polypropylene. This one, 0.87. The answer was this one, 0.95. Okay. Okay, this I'll let you know in the next class. This question. Yes. Next, now we'll go for the question that problem. Yes. Okay. 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 So, density of water. Oh, why that? Yes. Yes. Okay. Let me see the which question is that? Hmm? Huh. Okay. 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 Yeah. Mm-hmm. But this is closer to the density of water. Okay. It's okay. Okay. Okay, okay. Then that will be the reason why this one high density polyethylene is more suitable. Yes, yes. Okay, okay. Thank you. Hmm. Close to. Okay, 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 okay. Got it, got it. Okay, okay. Yeah, we'll go for the question part. This one. I think this first part that day also be done, but I think for the continuation we'll start from the beginning, since this is the problem statement and we have to solve three questions. Question: a 5 mld effluent from secondary clarifier. 1 minute. Okay. Secondary clarifier having TDS as 2200 milligram per liter and TSS as 30 milligram per liter is being treated with a combination of ultrafiltration module followed by reverse osmosis. The UF produces 95 percentage of permeate, while remaining 5 percentage goes as concentrate reject and reduced TSS to 0, while TDS gets reduced to 460 milligram per liter. Further, further the RO produced 3.2 million liter per day permeate with 20 milligram per liter TDS. Based on the information, answer the following. The total solid removal efficiency of UF. So you remember that how do we calculated this? First of all, I'm just writing, just putting a graph. So this is first of all 5 million liter per day effluent from secondary clarifier. So first we have UF module, followed by we have RO, right? Then first of we are initial influent which is given to the ultrafiltration is 5 mld, and then it is having TDS 2200 milligram per liter and TSS 30 milligram per liter, and is be treated with the combination ultrafiltration and then more followed by reverse osmosis. The UF produces 95 percentage permeate. So 95 percentage permeate it is uh, treating, and remaining 5 percentage goes as concentrate. So which one goes to RO, 95 or 5 percentage? No, 95 percentage is not going. This one, this 5 percentage, it is going to the next one. 5 percentage. No, this 5 percentage going into the RO, then and reduce TSS to 0. After that, TSS becomes 0, while TDS 460 milligram per liter. Further, RO produce 3.2 million liter per day permeate with 20. It has a TDS 20 milligram per liter. Okay, so the UF produces 95 percentage permeate while remaining 5% goes as reject and reduce. Here from the UF, see from the UF, TSS becomes 0 and TDS it is 460 milligram per liter, and it is giving into the RO. Then RO will treat and it is producing 3.2 million liter per day of permeate and having the TDS of 20 milligram per liter. So now we'll solve the problem. First we have to calculate the total solid removal efficiency of UF. First of all, we'll start from um, first UF. Okay, so here, so first you we know that inflow rate it is given. Inflow rate is 5 million liter per day, right? That we know, and then from this we can calculate uh, the volume of the inflow rate, or we can just say total volume of influent, that is equal to, so how do you convert this into liter per day? Million means what, 10 to the power 6. Yes, right. So that we can just write 1, 2, 3, 1, 2, 3. Okay. This is liter per day. Then total TDS in the influent, okay, equal to, we know that in liter per day this much, then this is liter per day into 2200 milligram. Okay? Yes, milligram per liter. Now how much it is coming? Now it is like in kg per day. How much it is? I think it is, it will become 11,000 kg per day. Is that right? Then total TSS equal to this much volume liter per day into TSS. So TSS is 30 milligram per day. Milligram per liter, right? This liter will get cancelled. Then I think it's 15, 15 milligram. Then you cut, then it is 150 kg per day. I hope till now it's clear. Yes. So now, um, so this is the inflow, right? Now you consider after the treatment in UF, it has permeate in the UF. Consider the UF ultrafiltration. Then it has permeate, and then it has concentrate. So now in the permeate, you go see TDS in the UF permeate TDS. So in the TDS permeate, it is given. So TDS 460, right? So how do you calculate the TDS in the permeate of the UF? You can calculate from. Then also there is one more point is given. How much this permeate is 95 percentage, and this concentrate is 5 percentage, right? So 95 percentage of this total 5 into 10 to the power 6 is how much? So that means, got na that point. This is the total inflow. Then you have to take 95 percentage of this 5 into 10 to the power 6. That 5 into 10 to the power 6 into 0.95. I think that will come. That will come like 4,475,000 triple. Yes, that is liter per day, right? Into 460 milligram per liter. So this get cancelled, and then the TDS will be, TDS will be 2185 kg per day. I hope it's clear now. Then the concentrate is 5 percentage, right? And also here you know that this is 2185 is right, right? It's 47. Okay, okay, sorry. Yes, yes, yes. This is, huh, yes, 4750 triple zero into 460. Then 460 is given. See here, this one, this one. Yes, here it is given TDS. Got that? Yes. Okay. Now, now we have to calculate concentrate. So when we see the concentrate, we know this is the TDS of the permeate. Then we know already the TDS of the inflow also, and like that TSS. Here what you have to do is this TDS. So how total TDS? We know the total TDS, right? So the total TDS value equal to, okay, total TDS in the concentrate, let's say concentrate, which will be equal to total TDS in the permeate, and then minus total, this is total TDS minus total TDS in the permeate. So the total TDS in the concentrate, which is here, because if you add the total concentrate in the TDS concentrate in the permeate plus concentrate, you get the total TDS. So to calculate the TDS in the concentrate, you can just minus from the total TDS. So the total TDS value, what is the total TDS value? This one, 11,000 minus total TDS in the permeate. Permeate is here, 2185, which is equal to 8815 kg per day. Is it clear till now? Just please refer. Like I just quickly show the question. So you see the screen here. The UF is here, RO is here. The first initial inflow 5 million liter per day, and TDS in that particular wastewater is 2200 milligram per liter, and TSS is 30 milligram per liter. That is the UF. It will treat, this UF will treat this wastewater, and the 5, this 95 percentage is the treated one. Then 5 percentage will go into the RO. Then what happens after this particular stream has TSS 0, then TDS is 460 milligram per liter. Is it clear? Okay. And this one, okay. Now So when we see TSS, so what is the TSS in the UF permeate? Permeate UF 0. And then, okay, sorry, I have deleted. What is it? Okay, did you write till that? I hope that guys have written till that. Just see TSS in the UF permeate. Permeate it is 0. And then TSS in the, this is in the permeate. And now TSS in the concentrate. TSS in the concentrate, it is given 150 kg per day. TDS, this is the TSS in the concentrate, that is 150 kg per day. Now total solid removal efficiency of UF. So total, we have to calculate total solid removal efficiency of UF. So first we know that A, we can write total solid in the influent. What is the total solid in the influent? How do you calculate that? Total TDS plus TSS, which is equal to, what is the TDS in the influent? Okay, have you guys noted down? No. Okay. Okay. TDS value is 11,100 kg per day plus TSS. TSS is 150 kg per day. And then total will be 11,150 kg per day. That is the total solid in the influent. The next point we should know total solids in the UF permeate. UF permeate. Okay, this is also like total TDS in the permeate plus total T, like it is equal to tot TDS in the permeate plus TSS in the permeate. So TDS in the permeate, okay, TDS in the permeate which we have calculated is 12185 kg per day plus TSS in the question itself it is given. After UF treatment, TSS becomes 0 for the permeate. That means this is 0, which is equal to 2185 kg per day. Then we should have concentrate. Total solids in concentrate. That means TDS in concentrate plus TSS in concentrate. So that is equal to TDS in the concentrate. So TDS in the concentrate is 8 88 15 plus 150 kg per day. So this will become 896 kg per day. Then how to calculate the removal efficiency? From this, can anyone say how do you calculate the removal efficiency? Removal efficiency is equal to total solids influent in the influent minus total solids in permeate divided by total solids in the in influent. That means total solids in the influent that we calculated. That is 11,150 minus total solids in the permeate 2185. Total solids in the influent 11,150. Then what you have to do for the 100? That means it will reach what is the value? It will reach the 80.5 percentage. Is it clear? It's understood now, like what how the steps came. So we should know total solids in the influent and total solids in the permeate, so that we can calculate from the percentage it is given, and then we can just put it in the formula. We will get the efficiency. So the option here is, it is near D is the answer. Now next part, the concentration of suspended solids in the reject from UF. We have to calculate the concentration of suspended solids in the reject from ultrafiltration, that step. Now whatever we knew or we have calculated in the previous step, that we can write. First, TSS initial TSS, it is given. See, initial TSS is given 30, that is for the influent, 30 milligram per liter. Okay, then influent flow rate also we know. 5 into 10 to the power 6, 10 to the power 6 liter per day. These 2 points we know. Then also, this is the total volume. This is what we have is million liter per day we have. That is, you know that 5 million liter per day. Then what the total TSS of the influent also we know, right? What then see, I will just draw this UF compartment, and then we are giving this TSS 30 milligram per liter, and then influent this we are treating. It is given, see here, it is given 5 million liter per day, 5 mld. Then the TDS also it is given. TDS is 2200. TDS 2200 milligram per liter. TSS equal to, TSS is given that, yes, 30 milligram per liter, that we have calculated. Here I have just written 30 milligram per liter. That is TSS. Then we have calculated also the output stream parameters. So now you can calculate what in the previous question we have calculated the total TSS. TSS we have calculated here, I guess. Yes, okay. I'm writing. So you can write here total TSS in the influent equal to volume into TSS concentration. You can write as we have 5 into 10 to the power 6 liter per day into TSS in the initial stream, that is 30 milligram per day. So that will come like that, we already have value 150 kg per day. Now the concentrate in the TSS in reject from UF, that we have to calculate. It is in milligram per liter we have to calculate. Now, okay, keep total volume of the concentrate. Volume of concentrate, that is from UF. Okay, so I think we have calculated volume of concentrate. Concentrate is 5 percentage, which is given in the question itself. So that is concentrate volume from the we have calculated in the previous question itself. It is 5 percentage. That means like from 5 into 10 to the power 6 liter per day into 0.05, that is 25013 liter per day. So then total TSS in the concentrate. Total TSS in the concentrate, uh, that is given in the question only. Right? Total TSS for the permeate it is becoming 0, but for the we have calculated in the second, anyone wrote it? The TSS concentration in the reject concentrate. Okay. Okay. Yes, TSS in the UF concentrate. Yes, 150 kg per day. Okay, then how do you calculate the concentration of TSS in this suspended one? Like how do you calculate the concentration? Here that you can calculate concentration of suspended solids, suspended solids in reject from UF, that is from UF, is equal to total TSS in concentrate divided by volume of the concentrate. So total TSS in the concentrate 150, not 150. So it will be like, yes, 150 kg per day. Volume of the concentrate, that will come 250,123 liter per day. So then this day and day get cancelled. Then remaining this kg you can convert into milligram. So when converting into milligram, it will be like into 10 to the power 3 milligram. That will be 150 into 10 to the power 3 divided by 25012. That is 150. How much it is coming? 0.6 it is coming. I think there is some mistake because here answer answer is B, 600. Just let me see that how where I have done. 0, okay, 50 into 10 to the power 3 divided by 25 into 3 and 6. Sorry. Okay, 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 okay. Yes. Ha. Yes. Kg per. Okay, then it is 6. Then it will be like 1 5. It is like 150. Uh, triple zero will come, right? This weight. Yes, yes, right. Triple zero will come. So then this will be 60, right? 66 will come. Just let me. Yes, I did 150,000 divided by 250. Okay. But this zero, okay. But this zero, 250. Yes, Yes. 150. Yes. Gram. Six. Milli. Okay. Okay. Yes. Yes. Got it. Now I got it. Yes. 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 Okay. Now, yes. Kg to gram. I just take gram. It should be like milligram, right? This three and this three will be counted. So 10 to the power 6 will come. This is the point, right? Okay. Then, 250. Okay. The answer is in milligram. 600 is coming, right? Yes. Okay. Okay. Then 600 milligram per liter. So this is the second. Yeah. B is the answer. Okay. Now the last question will go very quickly. Thank you, Sangamitra. Okay. So the next question: what is the percentage of the treated water produced from the RO unit? Okay, that means what is the percentage of treated water? Okay, this is after treatment. How much percentage? How much? What like the percentage of treated water produced from the RO unit after UF? There is a RO unit. How much treated water? That means permeate water is generated in the RO. So now you know the percentage RO. Let's concentrate RO. So first is percentage of permeate. Everything is in RO, in the RO unit, equal to volume of RO permeate divided by volume of UF permeate. This particular quantity should be multiplied with 100 percentage of permeate. So here percentage. So here when we put the values, volume of RO permeate just given. See 3.2 mld. 3.2 mld volume of UF permeate, that I think we have calculated, right? UF permeate, UF permeate is, see this 95 percentage. So I think around this one, for this 5 into this 5 mld into 0.95. I think it will be coming for 5 into 0.94. Yes. Okay. 4.75 mld. So that is the percentage will be, mm, I think it is 0.3 to 0.67, right? 3.4.75. Yes, that is 67.3 percentage. Yes. Then this is the, what is this is the percentage of permeate. When we compare UF and RO permeate, this is called the percentage of the permeate. So this we got 67.3. So we can see from options given, A option is closer to what we got, 67. So the answer is A. This is the percentage of treated water, that means permeate, which is produced from the RO unit. Got it? So why we consider UF permeate here? Think this particular, as Sankamitra first told, this 95 percentage of permeate, I think this they are given to the RO. That's why they have considered this particular value, UF permeate also, as the inflow of the RO permeate. What I have assumed is, see, I have assumed a zero liquid discharge system. So in the zero liquid discharge system, what is happening is after the first step, see, for example, UF is here, then the permeate is generated. This permeate can go for some, this can be, we can take it for the other treatment, but what we have is 5 percentage concentrate we have. Again, we can, you know, process with some technology and extract maximum water. In that way, I have assumed, but from the final question, I think it's clear. They have, giving the permeate of the UF into the RO unit. That's why that inflow to the RO unit, they have considered the permeate they got from the UF system. Is it clear? Yes, sorry. Then I thought like this is a zero. Huh. Yes. Huh. Yes. 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 Right. Right. Yes. Huh. You are right. Hmm. I thought about this as zero liquid discharge. That's why I considered this 5 percentages going. From this only it is clear. 3.2. If it's 5 percentage, it is way far lower than this value. That's what you said, right? Yes, yes, because it's only 5 percentage. It is already crossing half of the MLD, 5 MLD that we got it. Yes. Okay, that is the answer. In anything like any other than this, any other points to be discussed for this question? So what they are giving is 5, they are giving 5 MLD to the UF, and then they have 5 percentage reject they are just putting, rejecting. Then this 95 percentage of the permeate they are giving into the RO stream, then treating this permeate, then producing permeate and concentrate. Yes. Anything else to be discussed? Is it clear or it is confused because of this? Clear. Okay. Any other thing like, as you said, like in MBR, this thing have to be discussed further. This point. Okay. 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 Any other doubt from this class? It's only simple. Okay. Okay. Thank you so much. Okay. Okay. We'll see next class. Yeah. Okay. Bye. Okay. Bye. Thank you. Yeah. Bye.